Hi, and welcome to the next video in the series for Alien Global Consulting mentorship series. This video is going to be about loops, and loops are very powerful concepts in computers and computer languages because it lets us repeat the exact same set of instructions over and over again, and the computer doesn't make any mistakes in between those and it doesn't get bored. It's what gives us the power um, of machines, robots, and AI. They can keep going, keep searching, using large data sets. And a loop is a very important concept that allows them to keep going. It's always said if you can do it once on a computer, then you can do it multiple times. And technically, it can go on forever until there's some unexpected error. One thing I always say to my staff and students is a good programmer knows when to stop. It is the first thing you should think about when you're programming any code. And so when you're having problems with loops, it's often because you haven't thought of when you should stop or all the conditions of when you should stop. Um, with that said, let's go ahead and look at loops. I have a couple of examples that I want to go through, and to save time in typing, I am going to paste a couple of things into the screen. So here you can clearly see I have set up some variables of type integer, logical, and integer. Um, the first code example is just to get us started. Now, in progress, there are um, three main kinds of loops. Two not dealing with database, two general programming, and one to deal with the database, more or less. But in most programming languages, there's usually two main concepts for loops. One is a set defined loop, which is what you're going to look at first. And then one is a conditional loop, which says, hey, did this happen? If it has happened, then I should stop. If it hasn't happened, then I should continue looping. I should continue doing the same thing. So the first type of loop that we're looking at here is a defined set count. Here we use our do clause, our do, that says do int count 1 to 100. And this is a new caveat here. Normally, if we just stop here, and this was our code example, this loop would count 100 times. It would work 100 times and then stop. And I could show you what that looks like. So this thing is going to keep going until it hits 100. But we're now going to go, hey, by the way, I want you to go in groups of 10. So what do you think it'll happen, right? It's not going to run for 100 because if we start by 10, it should only run 10 times. So it's going to go 1, 11, 21, 31, and at 91. Then the next one will be 101, but we said stop at 100, so there you go. So that's the first concept of loops, a set number of times to run code. And obviously, if you wanted to leave for any reason, you can do that. I'll show that a little later. So now we have a second example here. I'll just pull this, and I might start making some of the examples available to you in the materials folder. That way you can try them on your own. That should make it a little bit more fun. Here we go. So here, now we're introducing a new keyword here, time. So this keyword takes the time as seconds from midnight on the computer. And we're introducing our second type of loop, which is a conditional loop, which says, I want you to do while this variable, logical variable, log stop equals false. So then what I said is this is time plus 5. So 5 seconds later is my end time. So it says if the current time here, the function time, is greater than 5 seconds, then stop. Right? Then assign stop time and then say log time equals stop. Right? So this will go around for 5 seconds. Okay. There you go. That's the rest of the example. So we could see when it stopped. Just run that. And there you go. It came back. Oh, there we go. So you see it stopped after 6 seconds. Okay. Now we have a third example here where we're using the word repeat. Now, in the other examples, we had to set the conditions before we even started. With a repeat, this will run without anything, and it's very dangerous because it'll just keep running on its own. If you just have the code that says repeat end, and this is one of the things I was mentioned earlier on when I started about knowing when to stop. If I did this code would continue to run for technically forever until my laptop runs out of power or the computer chip no longer functions. And it makes it very dangerous. One of the things we want to think of as programmers is never to end up in what we call infinite loops or non-conditional stops. It's something we have to constantly guard ourselves against. And the other one is called deadlock. And that happens when two sources or two users or two programs or two web services are trying to update the exact same record at the exact same time. That's another thing that we try to avoid. So this statement here without anything in the middle is one of the most dangerous type of things we could have as a programmer, because everything looks as if it's running fine, but then we don't know how to stop it, or nobody will ever know that it's doing nothing, which could be put you in a very difficult position, and technically lose your job. Anyway, so this example starts with a repeat statement. So the repeat tells the computer, look, you're going to do whatever is in here forever. So now we're going to introduce a new concept here called a label. So what I'm doing is saying this label now is a reference, a named reference for anything that happens between the next transaction scope. So in progress, transactions defined what the computer is going to do at a certain level for a certain number of times, or a group of instructions that go together with the computer to do a task, and when that task is over, that set of transactions or transaction is done, then it moves on to the next transaction or goes back up to the transaction level that called it. We'll go through stepping through code at a later date. But this label is now attached to this entire section of program. So here we're just having another counter. We're displaying the counter and pausing it so we can physically see it, because the numbers would scroll by so fast we wouldn't. This happened in milliseconds, so it wouldn't or I wouldn't be able to catch it, and wouldn't be able to display on the screen. And here we have some code. It says if the count is greater than 10 and it's less than 15, then we're going to go to the next loop. We're going to go to the next label. So it's going to go pop up here. And then we have code that gets us out that says if the count is greater than or equal to 10, then we can leave the loop. So this has some interesting things. Again, remember that statement that I made in the beginning is very, very important. You have to know when to stop. So this happens all the time. We know that in a normal run, we want to stop after the 10th time. So this is code that we would have, and I'll run it this way. And this happens a lot in programming languages and real world scenarios. But then something comes along, and the rules of business have changed, or the requirements that we're given for the company has changed, and now these are the rules we have. So it's going to go all the way through, and then at 16 it's going to come out. So then not only do we have to be conscious of when to stop, we have to be conscious of the order of our program, because if this came first, this will get ignored because it's going to hit this one first and say, hey, I am 10 or greater, and come out. So those are the sort of things we have to be mindful as programmers of, the order of things, when we need to stop, and when we should be considerate of other users and other programs and other things that are going to interact with our code. Getting a little bit outside the loops, but it all comes together. Like I said, this is not a standard training. This is to get people up and ready for real world coding as quick as possible. So now we hit the infamous stuff at every database course, every data structures course that you've ever been to, and they say, oh wow, you have this powerful thing called nested loops. And I have an example of a nested loop here. Nested loops really came about in early computers so they could sort things out. So you had to have at least 2 columns or two sections to sort, and a third to hold. And this is where nested loops became a big thing in the 80s. But anyway, we'll show you that here we have a set number of loops. This is 1, this is 2, and this is 3. So we had talked about before transactional levels. So each of these colons kind of really defines a transaction level. So if we think about it, this is level 3, this is level 2, and this is level 1. And this area out here is level 0 or ground 0. I guess we shouldn't use the word ground 0, but this is the initial level in this particular run. So basically, we just do some simple math. We multiply each one down. So this is a 6 5, but yeah, 6 5 is 30. So this is just a fancy way of counting to 30. But first, it must do 1 and 2. Then it comes back out here and counts a 1. Comes back in here, counts a 1 and 2, then counts a 2. Comes back down in here, counts 1 and 2, then counts a 3. Then comes back up, counts that as a 1. And that's what the display will show. So in loop 1, we're counting. Loop 2, this is every 2, right? This is the first one finished. You'll see that jump to 12. So every 6 this will jump, every 2 this will jump, and then every 6 this will jump. So again, like I said, it's just a fancy way of counting to 30, but it shows you the power of loops. This stuff will keep going until it reaches the end. Now everybody has seen 30 revolutions. Of course, this inner guy is the workhorse, and it doesn't matter if we change these like that, we would still count 30, but now this transaction scope needs to go through 5 before it can go up to this level, and this now needs to go through 2 of these 5s before it can go up. Then you need to go through 10 before you can come up. I just run it so you see the difference. But there, the end count would not be any different, right? Because the math is just a simple multiplication of the endpoints. That should finish. I think we all get the idea. It's just a little bit more to run, so I'll let it. I had bigger numbers before, and then I realized that would not have been wise. So now it's all complete. All right. So that is the idea of nested loops. Hopefully we get to do some logic programs, and when you guys let me know what kind of projects you guys are interested in, we'll see how loops and other things play. So now I'm going to do a more complicated example because, again, we want to get people up to speed and using as many aspects of this language as possible. So I'm going to introduce some database kind of types of logic, and rather than create and design a whole database and stuff like that, we're going to use a temp table. So I'm going to talk a little bit about the temp table, although it should be done later on down. Sometimes when we need to do logic sets, or a good example is we need to read a file of customers, we can create, before assigning it to the database, we can create a temporary storage area like a database in memory, and in progress that is called a temp table. In other languages like C or whatever, it can be called logics or record sets. But this is a temporary table for customer, which has a name, address, and cell phone number. And I use some of my students' names for this go around. So here I'm just creating customers so I can work with them. So here, a query is just another type of loop that checks into a database, or in this case a temporary table, or a memory store, or a record set. And the most popular query you'll see in progress is for each. And I do suggest people read up on that because this thing is very powerful. It has so many options. And of course, you can have nested for eaches, and then there's for first and for last. There's a lot of powerful stuff available to you in query. So here we just have a simple loop on customer that says for each customer, there's no other conditions, and this no lock just means that we're not planning on updating that record. I want you to show me the customer name formatted for 20 characters, and the label is going to be student name. You're going to do the address, and that's address line 1 and the cell phone number. And so very simple. We're just going to run it, and this is what it looks like. We have the student, the address, and cell phone going across as temporary records in a temp table that we created. And that's mostly about loops, right? So the important thing is what is inside the loop and how do we get out of the loop. That's things we need to consider. And just as a spot check, this is what that statement might look like in SQL. So in SQL, we would have a select statement. We're going to select the fields CH name, address, and cell phone from the table customer. This then would become our record set, and then we would have to send that record set to something to display it. And I always tell my friends, in my language, I can write and do stuff in 3 lines that takes you 20 lines to do. And it's one of the reasons why I like the Progress language. It is very powerful. It almost reads like English, especially if you name your variables and your temp tables and your database tables. Uh, it is very easy to wrap up very quickly and understand. Um, so I think that covers a lot of what I wanted to get to for this video. We have the examples of loops. We have the fixed loop, which is in Progress, the do expression for a specific count. A variable equals any number to another number, and you can step by. We have the other condition for the do while. This is very common in almost all languages. It used to be called do until, and yeah, I think it used to be called do until and do while. I think so. That's 80 stuff, and then it stops when there's a condition reach, or you break out of it. You can create ways to leave a loop. And then the next one was repeat, where it is going to go forever without any conditions, and you have to define all the ways to stop or leave that loop. And then we have this for each statement, which is a query, which people refer to as a query, but really is just a way of looping through data found in temp table, record sets, or a database. And I hope this has been meaningful to you, and I really would like people to think about the projects they want to do. Thank you.